Welcome you all. Today we are going to discuss the new thing which is known as a Turing machine. So इससे पहले वाले वीडियो में अपन ने देख चुके हैं फाइनाइट ऑटोमेटा क्या होता है, पुश डाउन ऑटोमेटा क्या होता है और उसके ग्रामर क्या होती है। फाइनाइट ऑटोमेटा की जो ग्रामर होती है वो टाइप 3 लैंग्वेज कहलाती है, टाइप 3 ग्रामर कहलाती है। जो पुश डाउन ऑटोमेटा की होती है वो टाइप 2 होती है और उसी के अंदर एक बाउंडेड पुश डाउन ऑटोमेटा जिसको टाइप 1 कहते हैं। आज अपन डिस्कस करने जा रहे हैं ट्यूरिंग मशीन। और ट्यूरिंग मशीन के द्वारा जो ग्रामर एक्सेप्ट होती है विच इज सिंपली नोन एज टाइप 0 ग्रामर और टाइप 0 सिंपली लैंग्वेज। So in this video we are mainly going to discuss a basic introductory part of Turing machine. In the next video we will take an example and understand detailing how Turing machine will work and how it is more powerful and more advanced as compared to the finite automata and push down automata. So a finite automata and a push down automata are only move left or right, but Turing machine can move in the both direction. So it was the drawback, or we can say disadvantages of push down automata and finite automata, that they can move only in a one direction, either left or right. But Turing machine can move both of the direction, left or right. In both direction it can move. It is a very powerful thing. Turing machine was proposed by Alan Turing in 1936. So it was firstly proposed by 1936 in the, we can say, by the Turing. It is Turing, not a Turing. Sorry, Alan Turing in 1936. So 1936 में it was proposed. It is used to accept a recursively enumerable language generated by the type 0 grammar. So there are basically four types of grammar. Type 3, which is known as a regular grammar. Type 2, which is known as a we can say context free grammar, or we can say type 1, which is a bounded with context free grammar, which is simply known as a bounded push down automata. And now the grammar which is acceptable by Turing machine, it is simply known as a type 0 grammar. The language is known as a recursively enumerable languages. A Turing machine consists of a tape of infinite length on which read or write operation can be performed. That is very important. So it contains a tape. Tape, it means a storage media, or we can say memory, which can be able to read the things, read the input, or store the input, or write the input. So this tape are contain the inputs, which is we are going to test on our Turing machine, and it tape is also able to write the data into the particular tape. Another thing is that it is infinite. It means it having infinite length. We can infinitely add the string inside the tape. The tape consists of an infinite cells on which each cell either contains the input symbol or a special symbol called a blank. So it is also one of the important things. The tape of push down automata at the both end contain the a special symbol which is known as a blank B. So here we are noting that as a B. So B as a special symbol, suppose it is in a tape. Inside the tab, it contains the string of input string which we are going to test on our Turing machine. So here it contains the input string, and the both end, if we can say it is the left end, or we can say it is the right end. At the both end, it contains the special symbol, we can say B, or we can say B over here. Not a single B, we can add multiple number of B's, which is simply represented the step are going to blank over, or we can say it doesn't contain an input string beyond this B or beyond this B. Toward this B is represented the blank over left side, and right side B represents the blank over right side. So it is contain a special symbol which is simply known as a B. So a tape contains the two things, either each cell either contains the input symbol or a special symbol called the blank symbol. When tape is unbounded, so it is unbounded, it is unlimited, we can say infinite. It also consists of a head pointer which points to the cell currently being read, and it can be moved in the both direction. And it contains a head which currently read, we can say currently reading the input string, and it move either a left direction or it can move either in the right direction. So it is a head is a pointer which is pointing the string symbol which is currently used to read. Or after reading or after performing the operation, this head can be moved to the left direction or can be moved in the right direction. It is a very important point because finite automata and push down automata are moved in only one direction, but this Turing machine can move either in left direction or right direction or both. It can move once at a right or once at a left direction. So it moves toward both directions. Now here is a graphical represented of this representation of the same. So it is a tape which is we can say this one, it can say unbounded, it doesn't having any boundation, and in between it contains the input string which we are going to test, and at the both end, at the left end and at the right end, it contains the blank symbol B, which represent now the tape beyond this symbol will be empty. So it is a tape, it is a read write head which is pointing to the string which you are going to read, and it is a finite control which controlling the header where it goes to move left or right and which things it's going to read. So it is a graphical representation of a Turing machine. So here we can understand the things. So Turing machine will be a machine which accept the language is known as a recursively enumerable language, or the grammar which is known as a recursively enumerable grammar, or type 0 grammar. So it is a 4 types of grammar. So Turing machine is a act as a machine, or we can say acceptor, which tells us that particular things is recursively enumerable language or not. Now we define it with the help of the tuple 7 tuple variables. We can say it contains the 7 things. It is a Q, the sigma, then toy, then transaction function, then Q naught, B, then F. What does it mean? Q is a finite set of states. So in the machine, there are finite set of states. It input alphabets or symbol. The various type of alphabet which we are going to use to read on a Turing machine are represented by the input symbol or input alphabet summation. Then toy, tape alphabet. Tape in the sense in the tape which data is consists. That is a tape alphabet. Transaction function. A transaction function, we can say the function which represented as what is a current state, what we are going to reading a current now, and after reading that current things, where to go on the next state and what will be the current state, or what is the top of the tab, or we can say top of the tab alphabet. I will show you the function also. So Q naught, it is an initial state. It is belongs to from the, we can say Q. It is not a summation. It is a Q. Q is a set of all states. So Q naught is belong to set of all states. After then we can say toy, which is capital B, which is a blank symbol, which is a belongs to tape alphabets. So B is simply a tape alphabets which reside inside the tape to represent the blank. F is a finite set of finite state. It is also belongs to Q. So it is a Q, not a summation. It also belongs to set of states. So it is our transaction function for, we can say, Turing machine. So Q is a current state, and it is toy represented the top of the stack. Suppose here what thing will be top of the tape. Suppose here is a blank. So what is the top of the tape? It is a blank. When we apply a particular variable comes blank or any string like a or any string like B, anything, any input string. So tape contains the two things we already read, that it maybe contains the input string, or either it can contain the blank symbol, spatial symbol. So Q is a current state. Suppose we are at a current state and there is a input at the top, we can set tape. Then we move to the next step and we also have the new symbol in the top of the stack, and we are going to move either left or either right. So it is a transaction function for a Turing machine. So it is a simply formal definition of Turing machine. So what is a Turing machine? Turing machine nothing but a special machine which contain the unbounded tape which can, and one head which is moved left or right in the both direction, and tape is unbounded. It contains any amount of data and it having the input symbols and blank symbol, and one is a finite control which controls the header to move left or right and reading the data. And another thing, it is having the advantage over push down automata and Turing machine, push down automata and finite automata, because they are moving only one direction, but Turing machine can move in either in the both direction, either left or right. And it contains the seven symbols, which are, it is a tuple of seven symbols which is represented over here, and it is a its transaction function. So it was a Turing machine. So in the next video, we will have a look about an example of Turing machine and going to understand little bit more deeper that what is a Turing machine and how it is practically used to solve the questions. So till now, thank you very much. If you have any question, then please ask your question in the comment box. I feel very happy to answer your question.